Hello, good afternoon all. This is Dr. Abdul Pasha. So here our course about power system, operation and control. In this I'm going to give presentation on voltage control compensation techniques and power factor correction. So earlier we discussed about the control strategies and that may also collaborated with the excitation system for the particular given mission. So synchronous machine excitation studied, and here control of voltage and compensating for lag of voltage cases and power factor correction method. Power factor correction methods. So coming to the introduction part, usually in the power system network, voltage at various buses are supposed to be increase or decreasing. This is due to its daily consumption by the load consumers. So to ensure about make sure the constant voltage to the consumers, various techniques are going to be utilized. Usually customers are nowadays increasing day by day. So load consumption is more, then it is necessary to compensate for the lag of response. Then voltage compensation is the best suitable method. So when the voltage is below the required level, so reactive power produced by the inductance, they need to be offset by the capacitors. So number of capacitors are used. Number of capacitors are used as one of the capacitor banks. One of the capacitor banks, they usually provide or make voltage balance. Voltage balance. So this is the voltage balance of the circuit. So usually we may treat the examples as synchronous condensers, shunt capacitors, series capacitors, tap changing transformers. So these are the best suitable examples for making compensation of the voltages. Synchronous condensers are phase advancers. They provide suitability of the voltage control. And we also connect shunt of these elements. So couple of shunt of these capacitor combination that will provide this connection across the line that may creates more power factor and provides the suitability of the voltage control. And also we treat a series capacitor. Shunt capacitors and series capacitors, they provide suitability combination. And one of the tap changing transformers means they can regulate the voltage to the required level. So usually we provide step up transformers at generating stations. So their expectancy of loss is more when the line is going to carry the power certain distance D, then there may be the drop in the line. So this can be overcome suitably by the providing tap changing transformers. They can regulate the voltage to the suitable extent, means they have the considerations about these conditions. So when the voltage is above the required level, when the voltage is above the required level means usually when you see at the load end, we need to reach the exact amount of voltage means the transmitted voltage should be higher. That means 10% extra of the voltage we need to send to the actual value. For the actual value, we need to send 10% of the extra. Why this is? Because this 10% when it reaches to the final end, load end, then it may neutralized as loss. Neutralized as a loss coefficient. As a loss coefficient in the middle of the line. So the actual amount is going to be transferred, whatever the power you required at the load end. So here this makes the suitability of the cases. That means when the voltage is above the required level, reactive power produced by capacitance needs to be offset by the inductance. So this inductance can do the adjustment of the voltages to the requirement. So that arrangement is supposed to be referred by shunt reactors, static wire compensating devices. Shunt reactors and static wire compensators device, they look into these cases. Next, voltage control in an electrical power system is very much important for proper operation of all the electrical power equipment. That is to prevent the damage like overheating of the generators and the motors, and also to reduce the transmission losses and to maintain the ability of the system to withstand and prevent the voltage collapse. We need to take over about voltage control phenomena. So we always supposed to be think of that in practice this is to reduce the reactive power to improve the system efficiency. That means this is under acceptable to some levels if the system is purely resistive or capacitive. So it makes sure that some problem in the electrical systems, this may can easily dominate the system behavior. So AC system supplies or consumes two kinds of powers. That is, one is real power and another one is reactive power. So real power accomplishes useful work while reactive power supports the voltage that must be controlled for system reliability. So this may be taking the reliability considerations. So reactive power has a profound effect on the security of the power system networks because it affects the voltage throughout the system. That means voltage can be maintained constant by using compensation techniques. So voltage fluctuations between the sending end and the receiving end voltage can easily be maintained by controlling the reactive power in the whole system. So generally we have two types, that is internal control and external control. So here we should remember that the internal control in the synchronous machines, the excitation of the alternator is going to be controlled. So here we discussed earlier systems, the concept of excitation system voltage control for the given alternator. From that, we are going to treat some compensation methods. So in power system network, we have discussed the external control of voltage fluctuations. Those are supposed to be known as compensation methods. They are shunt capacitors, shunt reactors, series capacitors, and finally synchronous condensers. Usually they act as an overexcited machine. An overexcited synchronous machine can act as one of the synchronous condensers. So one of the other devices they are existing are synchronous inductor, synchronous phase modifier. These are also known as phase advancers. So among these, the first three compensators are static equipments. They may be the next three are dynamic compensators. So here we should remember that according to the gate patterns, we learn about mostly concentrated on static compensating devices. They give the suitability of the voltage compensation. Shunt compensation. What is shunt compensation means? For high voltage transmission lines, the line capacitance is very high and it will plays a significant role in the voltage conditions of the given receiving end case. When the line is loaded, then the reactive power demand of the load is partially met by the reactive power that should be generated by the line capacitance, and the remaining reactive power demand is supposed to be met by the reactive power flow throughout the line from the sending end to the receiving end case. So by placing shunt capacitor or shunt reactor during the under voltage or over voltage conditions, we can overcome the voltage fluctuations very easily. So when the load is high, that means more than surge impedance loading cases, then a large reactive power is going to flow. That should be from sending end to the receiving end, which will result in large voltage drop in the line. So this makes the suitability of the system considerations. So to improve the voltage profile at the receiving end, shunt capacitors may be connected at the receiving end to generate and feed the reactive power. This should be treated as reactive power flow through the line, and which may consequently the voltage drop in the line is going to be reduced. So to meet the variable reactive power demands, requisite number of shunt capacitors they are going to be switched on in addition to the shunt reactors, which may result in adjustable reactive power that should be absorbed by the combination of the loads. These are usually treated as one of the major components in the power system network. So coming to shunt capacitors case, this method is usually used to improve the power factor of the system. This will enhance or hikes whole power factor. So whenever an inductive load is connected to the transmission line, power factor lags because of lagging load current. That is, to compensate a shunt capacitor, it is connected which draws current that should be leading to the source voltage. So they also improve the voltage stability and reduces the network loss. So to improve the power factor also means that should be designed with higher power transmission capability and also increased control of the power flow case. So here are some expressions related to this. QC equals to P of tan phi 1 minus tan phi, where receiving end is Vs Vr by XL cos delta minus Vs into Vs by XL case, where Vs is the sending end voltage, Vr is the receiving end voltage, and XL is the inductive reactance at power factor angle cos delta. So when this product is treated, then phi 1 becomes angle before the compensation method, phi 2 becomes the angle after the compensation method. Here is we considered with a simple two bus system. This is bus 1, this is a bus 2. So here source of voltage applied Vs at an angle of Q, Ss equals to P plus JQ, Sn equals to P plus JQR. This is the sending end voltage, this is the receiving end voltage. So here number of capacitor is connected here as it is to the load as P plus JQL as a cell in manner. So when the line is connected in such a manner, then receiving end voltage expected to be high to the load. So this is with the Q quotient S equals to P plus JQ, PR plus JQ, then load connected becomes like this, and one of the capacitor is connected. Then from this diagram, the receiving end of the quotient QR becomes QC plus QL. So for usual case of unity power factors, the receiving end will be existing with QR as QC. So if XC is 1 by C omega, that becomes the reactance of the shunt capacitor. Then the reactive power generated or leading in reactive volt amps, that should be done by the capacitor itself. Then QC becomes VR into VR by XC. So here VR product will be taken as the 2 power of C omega, where angular frequency is treated as omega. Shunt reactors. What are shunt reactors means? Shunt reactor is used to absorb the reactive power, which means it is used to compensate the undesired voltage. So this is used to make the compensation of line capacitance as Ferranti effect is considered. What is Ferranti effect? Usually receiving end voltage is higher than the sending end voltage. Then that is associated with the Ferranti effect concept. So sending end voltage is higher than the receiving end voltage. Shunt reactors reduces the voltage when the receiving end voltage is higher than the sending end voltage. That means it increases the energy efficiency of the whole entire power system network. So here it is the most compact device commonly preferred for reactive power compensation in long high voltage transmission lines and also in cable systems. That means if XL equals to L omega be the reactance of the shunt reactor, that is with the inductor, then the total reactive power absorbed VARs, reactive volt amps, absorbed by the shunt reactor is QC equals to VR into VR by XL as VR cap 2 by L omega we will treat. So then QL equals to PL tan phi. So this combination again treated with the two bus system, bus 1 and bus 2. This is bus 2, this is bus 1. This is the source of excitation. Source of excitation. So with these two combinations of 1 and 2, the whole two bus system is going to be existed. To control over the receiving end voltage, usually one shunt reactor is installed and switched in during the light load conditions. So coming to providing the series compensation strategy. So this is basically a powerful method to improve the performance of extra high voltage lines. So it contains the capacitors, they are connected in series with the line at a suitable locations. So that means by using series compensation, it will increases the transmission capacity, maintains the system stability usually. So increase in transmission capacity means losses are reduced. As the loss coefficients are more, then transmission efficiency is going to be increasing more and more. So the power transferred by the capacity of a line usually represented by P equals to EV by X sine delta. X sine delta. E is the sending end voltage. So here V is the receiving end voltage. Xs is the reactance of the line. And here delta is treated in between E and V. That is called phase angle. So power factor without and with compensation is considered. That is P1 equals to EV by XL sine delta. So where K is the degree of compensation here. So economic degree of compensation in the lines is supposed to be in between 40 to 70%, where it should be K less than 1. So that is existing in between zero point 0.4 to zero point 0.7 value. So P2 becomes EV by instead of XL, we need to take the difference of XL minus XC. That gives you the one of the capacitive reactance quotient. So P1 by P2, when you make these two equations ratio, P1 by P2 is XL minus XC by XC. You can write this XL minus XC as 1 by 1 minus XC by XC. When you do this simplify, then you may get 1 by 1 minus K. What is K here means? K is called degree of compensation. K is called as degree of compensation method. So what happens? This means economic degree of compensation in the line is ranges in between 40 to 70%. Economic degree of compensation is lying in between 40 to 70%, where its value is less than 1, K less than 1, and K may be 4 point, or 0 0.4, 0 0.5, 0 0.6, 0 0.7 like that. So the K value should be in such a manner. So improvement of system stability, how it can influence improvement of system stability means for the same amount of power transfer and same value of E and V, in the case of series compensated lines, it will be less than that of uncompensated lines. That means a lower the value of delta means better system stability. So P equals to EV by XL sine delta 1. Similarly, EV by XL minus XC sine delta 2. These two coefficients are going to be treated individually, and sine delta 1 by sine delta 2 becomes XL minus XC by XL coefficient. This gives the one of the values of ratios of delta 1 by delta 2 angulars. So series compensation offers most economic solutions for the whole power system stability as compared to the other methods like reducing the generators, reactants, bundled conductors, increased number of parallel circuits. So when the line is drawn from here, excited with the source Vs, so the sending end voltage becomes P plus JQ, suffix indicating sending end voltage, and receiving end voltage becomes this one. This is the receiving, this is sending end voltage. So here also P plus JQ. This is called receiving end voltage, this is called sending end voltage. So what happens means here the two lines are supposed to be separated with the load combination. They treated as PL plus JQL, which is equals to S suffix L. This is the final load combination we need to take. So voltage control can be done by making power factor correction method. So power factor correction means bringing the power factor of the AC circuit nearer to 1 by using the equipment which absorbs or supply the reactive power to the circuit. So usually power factor correction can be done by using capacitors and by the synchronous motor in the circuit. This will make the power factor correction, that is majorly once again capacitor and the synchronous motors. They can abruptly change the power factor ranges to the suitability content. So power factor correction will not change the amount of entire true power, but it will reduces the apparent power and the total current that should be drawn from the load case. So most economic value of the power factor lies in between 0.9 to 0.95. So if the value of the power factor lies below the 0.8 approximately, then it draws more current from the load. So large currents can increases the losses and they requires large conductor, thus it can reduces the cost of the whole system. So loss can be reduced easily here by corresponding to the power factor of the whole network. So power factor correction methods are used here. Delta and star connected capacitor banks. These can provide suitability of the voltage control. So power factor correction methods are mainly classified into two types by using capacitor or through the synchronous condenser. So power factor correction by using capacitor bank in three-phase systems. The power factor is improved by connecting the capacitors in star or delta connected band. So star and delta is connected as one of the banks of the capacitors. So star connection is shown here with the three resistor combinations are connected, and here is the capacitors. They are delta connected in nature. We are giving three-phase supply here to this three-phase load, and this is about star connected capacitor bank. So the same aspect, it is also connected to the one of the three-phase loads, which will be treating the capacitor banks arrangement. So capacitance requires in star connection of three-phase transformer is equal to 3 times of the capacitance that required per phase. So when the capacitors are connected in delta, so the working voltage of the star connected bank is 1 by root 3 times equals to the one of the delta connected bank. So for these reasons, capacitors are connected in the delta connection in three-phase system for power factor improvement case. So delta connection is also suitable or better for the capacitors. They are designated for high working principle arrangement. So this may makes the system suitability and the control over the system. So here power factor can be corrected by using synchronous condenser methods. So power factor can also be corrected by installing specially designed induction motor that should be known as synchronous condensers. So synchronous condensers was running without the mechanical load. So it is connected in parallel with the load case. So it absorbs and generates the reactive power by varying the excitation of the motor field winding. So synchronous condensers are basically used for improving the power factor in a big manner. That means bulk in nature. So output of the phase modifier can be varied smoothly. So synchronous condenser has some disadvantage like it is very costlier and installation is difficult, maintenance also more, and the operations are also not easy to carry out. So these are some of the references whichever I have considered, and this makes the smooth conduction of the video lectures. And we can refer some more with the website series and video lectures, and that gives the smooth presentation of the talk. So thank you for listening.
Like, share, and subscribe. Hit the bell icon for more updates.